So let's figure out if these two figures here are congruent. And again, if you're not sure which figures I'm talking about, there's clearly two triangles here, A, B, C, and C, D, E. So we're going to figure out if these two figures are congruent, and in addition to that, we're going to write them in the proper notation. Now, to prove that these two figures are congruent, at least currently, we have to prove that all corresponding parts are congruent. So let's start by just highlighting up the things that we know are congruent and marking anything that isn't already marked. So one thing that I noticed is that this segment and this segment are both equal to 3. Well, they're both segments, and they're the same shape, and they're both the same size, so they must be congruent to each other. In addition to that, I also see here that this piece, this angle, and this angle are vertical angles, so they must be congruent. So looking at this, I have a ton of, everything has a mark on it pretty much. Oops, you know what? I'm sorry, I forgot to mark that. That was supposed to be marked the entire time, so my bad. Where we're at right now is if you notice, we only don't know that those are congruent. Well, with this is where you have to start getting a little creative. How could I possibly prove that those are congruent? Well, I see that I have these two lines here, and then this third line. You know what? These are alternate interior angles. So if I knew that that line was parallel to that line, I would be good. Well, with this line and this line, I have a second transversal. And you can see here that these alternate interior angles are congruent. Therefore, I know that this must be parallel to this. AB is parallel to DE, and that's because the alternate interior angles, in this case, angle E is congruent to angle A. Okay, great. And again, that's not super formal, but I've justified my work. I know why those two lines must be parallel. And if these two lines are parallel, then I also know that angle B must be congruent to angle D by the alternate interior angle theorem. Well, good. Now I notice everything in here is marked up, so I feel like I'm at least in pretty darn good shape. And now it's just a matter of lining these up and making sure that I have them in the right way. And you can either use the angles or the sides to determine this. In this particular case, I'm going to use the vertices to do it. So I'm going to go ahead and color in here. I have A and E that are congruent to each other. So I'm going to put both of those first in my notation. Then I'm going to move on. Here I have B is congruent to D. Both have the 3 markings there, so I'll go ahead and notate that as well. The other thing that I'm being careful with, and you notice that I lined it up here, is that this is triangle 1 and this is triangle 2. Okay, you don't want to get those mixed up. And the last one's pretty easy. C is the vertex for both these triangles. And so we know that we could just put C for the final vertice. The very last thing that I tend to like to do is just to kind of make sure all of this is lining up real nice with the second thing that has to be congruent. So we have all of our vertices lined up and they're in the right order, and we've verified that they're congruent. Again, all corresponding parts must be congruent. So let's also check the segments real quick. It's pretty easy. I see that, I usually color code by using the opposite side. It's not always something you can do, but with triangles, it's pretty easy. And so we've got the side here, BC, for the first one, BC, and that's supposed to correspond with DC, and I see that it does. Those are both congruent to each other. Now I'm going to do the same thing here. Again, across from B, I have AC, And that is congruent to CE. And if I look here, that's AC, the first and last. And then I have EC, and that's the first and last as well. So those are corresponding as well in my notation. All right, the very last side to check is this one here, AB, which is the first and second terms in my first figure. And DE, those are supposed to be congruent based off of the initial conditions. And ED here is the first two there. So now I have verified that all corresponding parts are in fact congruent, and the notation, which tells me which parts are congruent to which parts in both figures, is right there. Now, is this the only strategy for doing this? No. Do you, however, have to verify that all corresponding parts are congruent? Absolutely, until we learn some new theorems where we can do a little less work to prove it.